Talks about series DC motors, and what is series DC motor is actually a combination in which the armature and the field windings are in series. This is actually the series field winding with a resistance R series, and we apply a voltage V terminal. This is a series motor, and the current will flow into the machine. If this is the I terminal, is actually the same current that is flowing through the series winding is actually the same current that is flowing through the armature. So for the fundamental equations for our series motor can then be EA equals to VT minus IA RA plus R series. So this will be the fundamental equation, and other than that, the armature current is equals to the field current, that is the series current, is equals to the I terminal. These are the two fundamental equations. So if you look at here, this is actually our series DC motor. Now what it is saying is that show the 250 volts. So the terminal voltage is 250 volts. Series DC motor with compensating winding and a total series resistance that includes this both armature and the series winding resistance is 0.08 ohms, and the series field actually consists of 25 turns, and the magnetizing curve they have shown here for this motor, and we can see that this magnetizing curve is not made in a comparison of current with the internally generated voltage. This magnetizing curve shows us the magnetomotive force and the internally generated voltage at a speed of 1200 rpm. This is at the speed of 1200 rpm, and they have made this magnetizing curve. So the first part is find the speed and induced torque of this motor for when its armature current is 50 amps. So in the first part, let's see what will be the internally generated voltage, induced voltage, when we will have this condition. This is the equation. So the terminal voltage is 250 volts, and the armature current he is saying is 50 amps, and RA plus R series they have given us. So EA becomes equals to 246 volts. So now what they are asking is, at this condition, what will be the speed and induced torque? To calculate the speed and induced torque, first we should know that what will be the magnetomotive force when a current of 50 amperes is flowing through here. So what will be F here? F is equals to NIA, N series, and that is actually we have 25 turns into the armature current, which is 50 amps. So the magnetomotive force is 1250 ampere turns inside the machine. So 1250, if we go here and we try to find 1250, though it will be something here, and that we can say will be around, assume 80 volts. So what this means is that when the internally magnetomotive force is 1250, the internally generated voltage is 80 volts when the motor is running at 1200 rpm. So again, if I will write that, for example, N0 is 1200 rpm when F is 1250 ampere turns, and EA0, the internally generated voltage, is 80 volts. Now the second condition is what will be N when the magnetomotive force is same. That means the flux is same, and the EA for the new condition is 246 volts. So this can be done by we can EA naught equals to K phi, and we can say N naught divided by EA equals to K phi omega N. So both are the same in this case. So the value of N will be then N naught, EA over EA naught into N naught. And this will become, what is EA? It is the new condition, 246 volts. It's the 80 volts. And what's N naught? N naught is 1200 RPM. So the new value will be 3690 RPM. This will be the new speed, or this will be the speed of the machine, the series DC motor, when its armature current is 50 amps. Now for the induced torque, now the last thing that we are required to calculate is about the induced torque in the machine. So one of the direct methods and good methods to calculate the induced torque is, we know that power converted in a machine, we know IA is actually equals to torque induced into speed. So the speed we know and the other factors. So torque induced can be calculated by EA IA over omega. EA is 246 and IA is 50 amperes. Speed, this is in RPM. So we would have to convert this into radians per second, and in this way, when we will convert it, the torque induced will become 31.8 Newton meters. So thank you. I hope it helps.